Hi there, guys. Adrian O'Sullivan here. Just carrying on from the last limits tutorials I had. In the last tutorials, I was using a separation method. So, and this tutorial is going to be more about L'Hopital's equation or rule. So, as previously stated, from the first example I did in the limits, it's going to be so if this is equal to 0 over 0, then you'll have to separate it, which you saw from previous examples. If they get complex enough, they will be kind of awkward to get to, and they take a lot of time to do. That bracket shouldn't be there after the 2, actually. Anyway, so when it's not separated, it looks like that when you graph it, and when it is separated, it looks like that, as you saw from the first tutorial I did on this limit. Another rule that can be used in this situation, or in a situation like this, is called L'Hopital's rule. So what is L'Hopital's rule? This is the derivation of, or the definition of L'Hopital's rule. The L'Hopital rule is if a function, if you're going from a limit from x is going to a, where the top part is f of x and the bottom part is g of x, if that's equal to 0, 0, or minus or plus infinity over minus or plus infinity, then it can be said that you can use L'Hopital's rule and you'll come up with the same answer. So it means that a function that goes from the limit of x going to minus a with that numerator and denominator is equal to the same limit of x going to a of the derivation of f of x and the derivative of f of x and g of x separately, where f dash is equal to f dot, or the derivative of fx in terms of x, just in case you're mixing up with notation. So I'll just do an example of it here. I'll do the example I did in the first tutorial, but using the L'Hopital's rule here. So x squared minus 5x plus 4 by 2 by, all in the brackets, x squared minus x minus 12 is equal to 0, 0. 0 over 0. Therefore, we can use L'Hopital's rule to get the answer as x goes to minus 4, or goes to 4. So, just to show it clearer, f of x is equal to x squared minus 5x plus 4, and g of x is equal to 2x squared minus 2x minus 24. But that's all in brackets, and I simplify that. And this is just stating L'Hopital's rule again. So all we have to do, instead of separating it and taking our time doing it, is just getting the derivative of f of x, which is 2x minus 5, and the derivative of gx, which is 2 by 2x minus 1. So when we fill in for the limit of x going to 4, when we fill this back in, we get this value here. Whoops. We get this value here, which is 3 over 14. Which is the same answer as the way we got, or it's the same answer as the one where we use a separation method in the first tutorial. So as you can see, I've just done it in basically 2 minutes, while the other one I had to find the roots of each function, cancel a few things out, and hope for the best. But this one is more like, it's a faster way of doing anything. So it doesn't seem that beneficial in that situation, but in complex equations, the separation method can be non-trivial, as I was just saying there, by filling in for roots, and you have to do long divisions, and anything over an order of x to the power of 3, it can get very awkward. So using the L'Hopital's rule instead, since the equation went to 0 over 0 as x goes to 4, we'll have a go off the example I did in the second tutorial, where the initial equation was x squared minus 3x minus 4 over x cubed minus 2x squared minus 5x minus 12. This is in the second tutorial. I'll give you a link right here. So this is just stating L'Hopital's rule again. Just in case you've skipped to this part. So if this goes to 0 over 0 or plus or minus infinity over plus or minus infinity, you can use this. So in this case, we can use it. So smiley face, yay. So I'll just write the initial equation down again. So that's equal to f of x over g of x. So when we take the numerator and separate it, and the denominator g of x is separated, we get these. And all we have to do is differentiate in terms of x. So f dash is 2x minus 3. And g dash is 3x squared minus 4x minus 5. What am I going to do next? I'll just go on to the next page. And then when we fill in for the limit of x goes to 4, f dash x over g dash of x is equal to, and I fill this in, I get 2x minus 3 over 3x squared minus 4x minus 5. And then when I leave x going to 4, or x going to 4, in other words, leave x equal to 4, we get this, which is equal to 5 over 5 over 27. Which, if you check back to the second tutorial, it's the exact same answer. Which is great. It saves so much time. So, as I was saying there, it does save a good bit much time, but just in case you think I'm thinking like, oh, like 1 second or something, let's make a graph here with the time spent with separation method on the left, the first method, and L'Hopital's rule. So for that example, the last example with the order 3 or x to the power 3, it took me 14 minutes to do the separation method and 7 minutes to do the L'Hopital's rule. That's like doing a 3-hour exam in 1.5 hours. So celebrations, yes. Ooh, fireworks. Woo! So thanks for watching. Comment below if you want. Cool, thanks.